Welcome to Insider's Guide to Energy EV Series. I'm your host, Chris Sass, and with me is co-host Neil Riddell. Neil, how's it going today?
Hey, Chris, we've got an exciting one today. We're going to be talking about a topic that businesses raise with me all the time. What happens to the battery at the end of an electric vehicle's life?
That is an interesting question. I think we've talked about recycling batteries, but is that really the end of the battery's life, right? So there's a big difference between when the battery's life ends and when the usable life of a battery for an EV ends. And I think that's what we hope to cover today. So I'm going to turn it over to you to get us kicked off.
So, today we're going to be talking to Matthew Lumsden from Connected Energy, whose business is focused on exactly what happens when a battery's usable life expires inside a vehicle, but then he makes additional use out of that battery. Matthew, why don't you tell us more about your business?
Hi, so Matthew Lumsden, CEO of Connected Energy. And as you rightly point out, our business is entirely focused on reusing electric vehicle batteries, deploying them in stationary energy storage systems, and doing that when they've come to the end of their useful life in an electric vehicle, or when they've started their second life, as I guess we say.
And how do you determine when it's reached the end of its useful life in an electric vehicle? How do you measure that? What are you looking for?
Okay, so the determining factor is, can you drive as far as you need to drive in your electric vehicle? So obviously, as you use your vehicle and as you charge your vehicle and as you even leave it standing, the battery gradually degrades. And there comes a point where it doesn't provide the utility that you might need of that vehicle. So typically that's perhaps 15% degraded. It obviously varies according to the vehicle. If you think about a bus or a truck, then they have very distinct duty cycles, very focused on the amount of range they drive each day. So if the batteries become degraded, they can't do what they want to achieve. So we typically take a battery around about 15-20% degraded, and then we move it into one of our systems. And it's obviously it's all around kilowatt hours. So we lose kilowatt hours, we lose the capacity to store energy, and then we move it into second life.
So if we're looking at a 100 kilowatt hour battery pack in a big vehicle, you're interested in it when it gets maybe to 85 or even 80 kilowatt hours of usable capacity. What actually happens to that battery?
Well, when we get it.
Well, more.
Okay.
How does it get to 85 kilowatt hours? Does it disappear? Is it
Okay.
unusable? Is it just really
So
inefficient?
as the battery is used, the chemistry in the battery gradually changes, and it ceases to be able to store, charge and discharge as much energy as it was in its first life. But it still has the ability to store a lot of energy. Hence, why we then move to second life. Typically, what we do is we will take a battery exactly as it was in the vehicle. So we don't change the battery in any way at all. We don't take the modules out of the battery. So we use all of the embedded technology that's been developed by the battery or the vehicle OEM. We use the battery management system, we use the safety systems, we use the cooling systems, and then we take that battery pack in its entirety after it's been tested, and then we build that up. We put multiple of these batteries into one of our systems, and then we can then create a system that's as large as we require, dependent on the number of batteries we put into it.
I guess what comes to mind to me is, a lot of these batteries seem to be built into the vehicles, or they're part of the vehicle when I get my vehicle. So how do you get this whole battery system out for the second use?
So we don't take them out. I mean, typically we get our batteries from the OEM, the vehicle manufacturer or the battery manufacturer. They remove them, but if you think about your EV, the battery is more part of the floor pan of the vehicle. So quite often it's actually cooled by, in the case of a Nissan Leaf, say, it's quite often cooled by the air blowing underneath the battery, or it might have a liquid system. But effectively, you need to take it into a service centre. They remove a load of bolts for sake of complication and drop the battery out. But obviously it's a professional process because these are heavy bits of kit. But quite often the car batteries are in a form factor that fits within the shape of the car or the truck or the van, sorry. But typically, if you're looking at a bus and truck battery, then they're much more sort of prismatic, cuboid shaped batteries that are easier to stack and build into a bigger system.
And when it comes out of the vehicle, the OEM takes it out and they deliver it to you. How do you know it's actually suitable or usable for any future use case?
So there's a number of models. So some of the batteries are tested before we get them. So we will provide the OEM with a specification of a battery that we're prepared to accept. And that, typically, as we mentioned before, involves it having a certain amount of kilowatt hours that we can use. Other batteries, particularly in buses and trucks, come with telematics data. So, sophisticated telematics used in fleets these days provide a lot of data about the health of the battery, how it's been charged and discharged, etc. So, all of these combine to provide us with a picture of the condition that the battery's in and how long we would expect it to last in one of our applications.
Now, if you've received the battery from an OEM, does this alleviate their need for the whole life cycle of the battery? Does that now become your challenge of what to do with the battery when it's no longer usable, or is the OEM still responsible for it?
Depends on the commercial model, but typically, unless the liability fully contracts over to us, it stays with the OEM. But interestingly enough, the world of OEMs has really changed over the last couple of years. Whereas if we take a step back a couple of years ago, we felt that OEMs were actually very keen to pass that liability on to somebody else. Whereas what's happened in more recent times is that the OEMs are now really keen to maximize the value of the battery, first life, second life, and end of life recycling, and also be able to demonstrate that that recycled material is feeding back into their new production. So there's a real move now for the OEMs to keep touch with that battery throughout its life.
And from a supply chain perspective, vehicles are now rolling out to more and more people. So we're seeing new vehicles hit the market, but you must be lagging the market by 8 or 10 years. So are you getting enough supply of batteries? Who's providing them to you?
It's just starting to ramp up now. So we anticipate there's going to be a significant ramp up probably from about 2026. But we're beginning to see that now. So I guess we saw this problem coming. So we're able to use a range of different batteries. So we're using 2 or 3 different Renault batteries. We're using 4C power batteries. We've integrated Land Rover batteries. Our investors include Volvo and Caterpillar, so we're in the process of working with them to use their batteries as well. So in the short term and potentially in the long term as well, actually, we're combining batteries so that we can move from projects that are a megawatt hour through to tens and hundreds of megawatt hours.
So the battery reaches the end of its usable life because the capacity is no longer there. The OEM removes it. You do some testing, and then presumably you construct it into some form factor. What do you then do with it? How do you deploy these second life batteries? What's the use case?
Yeah, so we our smaller systems are, if you imagine a 20-foot shipping container. So perhaps 30% of that container is electronics, and the other 60% is has racking and cooling system to contain the batteries. So we literally slot the batteries in on the shelves, plug them up, and then that becomes an integrated energy storage system that can deploy it on a industrial and commercial type site. The next phase of our business is moving up into much sort of larger utility scale systems. And then we'll have 40-foot containers that will just be full of batteries. And we will just plug those containers into the power electronics, separate containers, if you like, system.
So, how ubiquitous or how similar are the batteries? I mean, you've got two OEMs that you mentioned by name that are investors, and I assume you work with. Um, Are the batteries pretty standard? So, if I take 5 different brands of EV battery, are they still gonna fit in a 28-foot container, or do I need a different format to make these things work?
No, no. So typically, I mean, the good thing is, over a period of life. So if you imagine a Nissan Leaf battery, if you take it right from its whatever it was, 24 kilowatt hours right at the beginning through to its 60 kilowatt hours, the form factor as it evolves has changed very little. So we can interchange different generations of a Nissan Leaf battery, say, but when you move between different manufacturers, then all manufacturers will have a different CAN protocol, communications protocol to communicate with the batteries. They'll typically have different cooling systems. The batteries are different shapes and sizes. So a container load of batteries will last with that battery as it changes and it evolves. But typically, we'll have different formats of containers for different types of batteries.
Alright, so the formats stay similar. You've got different brands perhaps to
Yeah.
fit in the form factor. Um, but EV demand on a battery, so the software is optimized for maybe charging overnight or maybe a rapid charge, and then kind of the brake trickling in or whatever. But I'd
Hmm.
imagine that's a very different kind of a performance than I would have from having, let's say, backing up my data center or having some large thing dropped in my backyard to get some backup. So how does that work?
I mean, it's different, but there are a lot of similarities there. So it obviously depends how the energy storage system's being used. So sometimes these systems are plugged into the grid and they literally just charge and discharge to help maintain the frequency of the grid. And if you imagine yourself driving along your electric car, accelerating, the accelerating, so you're getting, you're charging and you're discharging with the regen, etc. So there's a lot of similarities there. And then if you imagine charging your car and budget, but then also driving down the motorway, you've got a long period of charging, long period of discharging. So you can actually put together the components of an EV duty cycle, and there are a lot of similarities between that and a stationary energy storage duty cycle. What we've actually done is we've taken degradation data from the OEMs, and we've used that to predict how we expect the batteries will degrade in our systems. And actually, they're pretty much bang on, degrading exactly as we forecast. So there clearly is a lot of similarity there.
So you've assembled these assets, you put them onto sites. Do you guys then operate and maintain the assets? So, are you doing both the business models of creating the asset, the physical infrastructure, and then operating it, or do you pass on the asset as a battery to someone else to operate?
To a certain extent. So we monitor the systems in real time. So if you imagine your normal EV battery and the safety systems on that, we have another safety system on top of that, and we monitor the batteries in real time. And also, if you imagine you've got a system with 100 batteries, all of which are slightly different, we also gradually adapt the algorithms to make sure we're getting best value out of those batteries. So we do that. We also provide service and maintenance support to these systems. And also we have our microgrid control software, which enables you to integrate the energy storage system with your site. So if you've got EV chargers or you've got PV, you might have a CHP plant on your site, we can control the battery according to the different assets. But other people, like to trade the asset, either trade the asset or alternatively provide flexibility to the grid. So typically we bring a third party who's a specialist in that kind of monetization, and they play with the system.
And can you give us an example of where you've done this? Where have you rolled out this system, and what are the examples of the value being created from that system today?
Yeah, so there's a nice project we've actually got at Cranfield University, where Cranfield have a big test site around an old airport. They use it for large scale testing and gradually building up that facility. So they have a decarbonizer site, but also they have an export constraint in that they have the generation on, but if they can't use all of that PV on site, they've got a problem because they can't export it. So we've got 3 systems on that site. One is the PV, so that if the overall site load isn't high enough, we can take that PV generation into our storage system. And then we've got a couple of others, that one of which provides resilience. So if the grid goes down, it may make sure that the water treatment works is still operational. And then we've got another one that can manage roads. So we can operate the system individually to solve individual problems, or we can control them all as one system. And very shortly, they're going to be linking into an aggregator so that those 3 systems can also be used to provide flexibility to the grid or to trade energy.
So this then means that you're getting that second life out of the battery, and you maybe get your 8 to 10 years in the car. How long can you expect that grid, microgrid, or even grid services battery to provide services for? Is it significantly less, or do you get a
No,
decent
no.
life
So
out of it?
we anticipate you'll get probably at least the same kind of time frame out of this in stationary storage as well. I mean, one of the things that we do that is slightly different is that we don't tend to use the batteries at such a high power as you use the vehicle. If you really put your foot down on the accelerator of the vehicle, you're pulling a lot of power from the batteries. Whereas we tend to use them at a slightly lower power, which means that that should add to the longevity of the batteries as well. So effectively we're doubling the working lifespan of the battery, and in so doing, if you compare one of our systems with a new lithium-ion system, then we've also got a carbon impact benefit of about 450 tons per megawatt hour installed, relative to installing a new lithium-ion system.
What kind of scale are you at right now? Is this just in the UK, or are you doing this larger market?
Okay, so we've got about 30 systems either installed or being installed at the moment in UK, Belgium, Germany, the Netherlands, and Sweden. At the moment, most of those systems are up to about 1.2 megawatts. But next year we start sort of deploying systems in multi-megawatts with a view to gradually moving up into utility scale. So next year we'll probably install a couple of systems that will be between 2 and 5 megawatts. So you're starting to move into systems which have hundreds of batteries rather than tens of batteries in them.
And then it sounded like you just use shipping containers, just like there were blockchain people and cryptocurrency guys I knew that use shipping containers. So in the supply chain, is there an endless supply of shipping containers? Because there's a number of businesses using shipping containers. So are we going to be making steel structures just for batteries at a certain point?
Excuse me. So I think there's a big supply base of shipping containers. I don't think we should worry about that too much. I think as we move into much larger scale systems, we may well look at a different type of container for them. And part of this, the challenge in our business is to make it work. You've got the whole value chain work. So you've got to work from battery suppliers to EV OEMs to people who are financing fleets, through to us as an integrator, through to people who want to buy or monetize energy storage systems. And part of what we're looking at the moment is, when this really moves into volume, will the battery suppliers just supply the container load of batteries to our specification, and then we just plug it into our control systems and power systems on site? So there's a lot of work going on to try to put the next layer of building onto what this industry might look like in 10 years' time, and how can we get it all working for real scale up.
So this is a question which I love, because you raised a decent amount of money, but you're still an SME playing with some really big corporate players, utilities, automotive providers. You're sat in the middle.
Yeah.
What's that like?
It's just moved from frustrating to fantastic, because when you go out and raise finance, and you get yourself a load of strategic investors, you have all sorts of great ideas on how you leverage these parties and how they're going to help you build the business. But quite typically, a huge corporate it might have a ventures division which is about investing. They haven't got a business unit in their group which is specifically designed to help the companies that they've just invested in. So it's very challenging to actually get that support out of the businesses. But really, I guess because of the fruitfulness that sector is starting to demonstrate, that we've really just engaged very well with our investors, and now it's we're starting to feel the value of those partnerships and starting to feel like scale up, I guess, with somebody holding our hand, which makes life a lot less risky, because it's taken a lot of time to get the planets to align. It's good that they are, and now it's going in the right direction, I suppose.
So I can see that things are going well now, but how did this journey begin? Because your background means that you've had to bring a lot of ideas and concepts together. What is your backstory to how this business started?
So my background prior to setting up Connected Energy was sort of in renewable energy consulting. But a lot of work on consenting for wind farms and PV, but also we had a power systems group, so very cognizant of some of the challenges associated with plugging things into the grid, and also the challenges faced by the grid when you inject battery generation, variable generation into that as well. So I guess 10, 15 years ago, we were talking about smart grids and storage then, but it just hadn't really happened. Around 2010, I kind of got involved with some strategic work with the regional development agency in the northeast, and the arrival of Nissan with their battery plants and their Leaf plants, and trying to create some trials in the region to get infrastructure going, demonstrate the vehicles, etc. So moved into electric vehicles, and that history of understanding the complexity of plugging things into the grid, understanding the role of storage, and sort of starting to put EV charging infrastructure in together sort of led to putting two and two together and thinking, well, there's a problem here. And then my technical director at the time came from the world of automotive, and he'd kind of spotted the delegation piece. So we kind of put all of that together and thought, well, maybe there's an opportunity here. And then we were fantastically lucky. We won a £3.5 million proof of concept grant from what was Department of Energy and Climate Change at the time, which enabled us to pull together a big proof of concept system. So, we did that, and then from there, we've just gradually, I guess, matured and industrialized the technology to get to the point where we're deploying them commercially and managing to attract some commercial investors.
Now, how do you compete with other grid scale storage that may not be using 80% battery capacity? So if I got my great new startup tomorrow and I decide I'm going to do some grid storage, and maybe I'm using battery technology to do it,
Okay,
how's that head
so
to head go?
that's the $1 million question, isn't it? So you always have with second life batteries, you all have some disadvantages. So because the batteries are degraded, they are less energy dense, which means the systems are big, which means the costs are higher. There are also communication systems in there that are legacy of the vehicles. So you have to put in additional communication systems in there as well. So there are additionalities. It's not a slam dunk, these things are dirt cheap kind of a situation. But by the same token, we've said that actually functionally we can provide exactly the same kind of functionality as we can with a new system. So to make Second Life successful, you have two key components. One is, can you create the enabling technology that gives you the functionality that is equivalent to a new system? And the second is, can you create a business model that provides you with the equivalent of the warranties and the performance guarantees that you would expect from a new system? So, I think one of the benefits we have experienced from our set of investors is that they come right from the battery through to project finance, through to utilities, through to recycling, enables us to create a business model which can be attractive to all those parties and therefore enable the industry to scale up. So, the big challenge is the warranties. So you have to look at a different model to provide a project investor with the same kind of comfort as they would get from a warranty for a flash system.
So I can see a world under which automotive companies are going to be looking towards a business like yours to go, I found a way to manage legacy batteries as they come out of vehicles. And to some extent, that enables them to get around some of the European directives around how they handle waste. And we've talked a little bit about the fact that most of the time the liability remains with the automotive company. So you've got an 8 to 10 year life inside the car, an 8 to 10 year life outside in this new environment. We're talking 20 years, but when do you start to see systems coming offline, and what do you do next? Do you pass it back to the automotive guys, or is there another plan?
So we will the batteries through, I guess, that next phase, which, typically if if a battery came out of a crashed vehicle now, the battery would be disassembled, parts would be taken out of that battery, potentially going into the service supply chain, and different components within that battery would be recycled in a different way. Whether when the battery's been in life for 20 years, there are parts there that could still go into the service supply chain, I'm not sure. But ultimately, we will manage those batteries through to a recycler, and then they will end their life, I guess.
So I guess one thing that I'm thinking about as we're having this conversation, if I take an old internal combustion engine car, drive it for 10 years, put 200,000 miles on the thing and it's dead, the value for scrap, maybe I pay someone to take it away, maybe I get paid a little bit of money for them to come take it away for parts. If you're telling me there's residual life in the battery, how does the EV owner, are they going to participate in this at all? Because, I bought a more expensive vehicle potentially. I've used its expected life up, but now you're telling me that it's not really used up, that it's actually a fundamental for something else. So is there a value that's going to trickle back to the owners in the residual? Because I don't think the used car market is showing that today.
Yeah, that's a really good point. So, some of the discussions we're now having. So you're exactly right. So obviously, what we can do is we can add a residual value to that battery, which can then be fed back into the business model that was used to finance the vehicles. So potentially, that should produce a lower cost financing model for whoever buys the vehicle in the first place. This has become a big part of certainly bus fleets. So, typically the battery will have an 8-year warranty. If we can provide at least an indicative value of that battery when it's subsequently replaced, and that feeds into that whole fleet finance model. So I think we're just getting to the point now where we can provide a pretty good forecast as to what the batteries are worth, and then that should be then fed back into future fleets and the way they're financed, and that residual value should ultimately benefit either the company that's buying the fleet or the individual that's buying the vehicle, I guess.
So there's a lot going on in your ecosystem, but one of the things that I'm always curious to understand, because you're looking into the future, what excites you most about what's coming next for connected energy? How do you see the future laying out?
I mean, I think exciting is pretty. I mean, the problem is the hockey stick, So there is a very clear hockey stick, and that's going to happen sometime between 26 and 2030, I guess. And our challenge for the next few years is, we've developed technology, we've proven that we've got 30 systems out there. We know it works, we know it's scalable, but then the next piece is all about the supply chain, and it's all about de-risking all the supply chain so that you can get an assembler to build all of these container loads of batteries. You've got to work out how those batteries feed from the OEMs to contain them. into the projects. We've got to make sure that all that's financeable. And all of these batteries are coming in from different parts of the world. At the moment we're just focusing in Europe, but even so, they're distributed around Europe. So it's a total sort of value chain model where you have to work with the battery suppliers to understand what their model is, link that into our model, link that into the person who's going to find the project, etc. So it's just a complex mesh of partnerships that you've got to develop. And our approach to all of this is, you have just got to open. It's not going to work. Somebody's trying to be, because it's got to work for everybody. So it's about forging really good partnerships and simultaneously getting all the pieces of work and scale up. So, I think we're going through or heading for 2 or 3 years of pretty exciting growth, I think.
Yeah, it's quite an exciting time. We've talked a bit about how the business comes together. And what about you personally? Are you driving an electric car today? What is it? And how did you find the world of electric vehicles?
So you hit me a point in my life, and I'm having a bit of a dilemma actually. So I've been driving a petrol car for years. My wife has to leave, and we've just put, at my request, an electrical salary sacrifice into the company. And to be honest, I'm actually just thinking, well, do I need a car? So at the moment, I have a petrol car, but in all probability, I'm just not going to have a car at all. My wife and I will use a car, and I'll use public transport more. And which is a bit of a disappointment because I was looking forward to spinning around in a Polestar or something, but I'm planning to go the next step.
Very cool. That's quite a personal commitment to make, to abandon the car altogether. You've taken us on a bit of a journey, Matthew, from when you received the battery after sort of 8 or 10 years coming out of the vehicle, how you then manage that battery into a new application, and the journey that we go on as you convert that battery into something useful before ultimately it reaches the true end of life, having had its second life. This has been really great, and I'm sure a lot of people are going to be very excited to hear about how we handle batteries at the end of their life. So thank you very much for being on the show today.
Thank you. It's great to meet you, and interesting discussion. Thank you.
For our audience, we hope you've enjoyed this episode, finding out the next life of your battery from your EV, what's going to happen to it or what could happen to it. If you enjoyed this content, please don't forget to subscribe. Follow us on the YouTube channel, follow us on our LinkedIn group, and we will see you again next time. Remember, this series is coming out every other week on the Insider's Guide to Energy EV series. Bye-bye.